In the previous video, we learned how to extract the greatest common factor. In this video, we'll learn a process called factoring by grouping, which involves multiple applications of extracting the GCF. Tip: try factoring by grouping on polynomials that have 4 terms. Now remember, anytime you attempt factoring a polynomial, inspect all of the terms to see if there's a universal greatest common factor. If so, you can extract it. If not, and the polynomial has 4 terms, then factoring by grouping may work. Here's the procedure. Group the terms into pairs that share a GCF. Factor out the GCF from each pair. Then factor out the remaining binomial GCF. So altogether, we're going to extract 3 rounds of greatest common factors. Let's try this on example 2. Factor the following polynomials by grouping. So notice on example A, all 4 terms do not share anything in common. That is, there's not a universal greatest common factor. But if we group these pairwise, we can find 2 greatest common factors. So if I look at the first 2 terms, notice they have a greatest common factor of x. So I'm going to take it out and factor it just from those first 2 terms. That's going to leave behind x minus 5. Now I'm going to keep the pairs separated by a plus, so I'm going to transfer the plus to the next line. Then I'm going to look at the next pair of terms. Notice they have a greatest common factor of 6, so I'm going to take the GCF out to the left. Then I'm going to divide each of those 2 terms by 6 to see that the leftovers would be x minus 5. Now on this line, we only have 2 terms. The first term is x times x minus 5. It's composed of 2 factors. And the second term is 6 times x minus 5, also composed of 2 factors. Remember, terms are separated by a plus or a minus, so that plus right there separates our 2 terms. So comparing these 2 terms, we can see that they both have an x minus 5. We would say that's a binomial GCF, or a 2-term greatest common factor. So like we always do with the GCF, I'm going to take it out to the left and record it. Then I'm going to divide each of those 2 terms by the GCF to see what's left. So if we take an x minus 5 out of that first term, x is left behind. There's a plus between our 2 terms. And if I take the x minus 5 out of the second term, there's a 6 left behind. So we have the polynomial factored. Now, of course, we want to be sure that it's correct. Remember, anytime you factor a polynomial, you can check with multiplication. In this case, we would check with FOIL. So if I multiply the first 2 terms together, we get x squared. The outside terms have a product of 6x. The inside terms have a product of negative 5x, and the last terms have a product of negative 30. Now, if we compare that to the original, now our 2 middle terms are out of order, but we could switch them and it would match the original. So we know we have it factored correctly. Okay, that's factoring by grouping. Let's give it another go on example B. So again, the first thing we look for all 4 terms, is there a greatest common factor that we could extract from all of the terms? And of course, the answer is no. Since this polynomial has 4 terms, it's a great candidate for factoring by grouping. So I'm going to group the first 2 terms together and identify the greatest common factor. Looking at just the coefficients between 6 and 15, the greatest common factor there is 3. Both terms also have an x. So the GCF just of those first 2 terms is 3x. So I'm going to extract it from those 2 terms. If we take 6xy and divide it by 3x, 2y would remain. Or I can think 3x times what would give me 6xy. 3x times 2y would give me 6xy. Moving on to the next term, negative 15x. If we divide that by 3x, that would leave behind minus 5. Okay, so that's the GCF taken out of the first pair. Now we want to extract the GCF from the second pair. Now, if we look at negative 2y and positive 5, they don't have a greatest common factor bigger than 1, or perhaps negative 1. But remember, on our first problem, factoring by grouping worked because those second two binomials matched. That's my goal in factoring by grouping. So I notice here the first binomial is 2y minus 5, and that's really close to what we have right here. The problem is the signs don't match. So what we're going to do is get a little bit sneaky. We're going to take out a greatest common factor of -1. Okay, so notice if I divide -2y by -1, that gives me positive 2y, and 5 divided by -1 gives me -5. Then we have achieved our goal. These second two binomials match. So remember, if you have a close match like that, but the signs are off, just factor out a GCF of -1. So once again, we've got two terms. There's my first term, here's my second term. And the greatest common factor there is 2y minus 5. So if I take the 2y minus 5 out of the first term, that leaves behind a 3x. And if we take a 2y minus 5 out of the second term, that leaves behind a -1. So we have the polynomial factored. And by the way, in case you were wondering, it's also correct to write the polynomial in this order. Because multiplication is commutative, you can write your factors in either order and still get the same answer. But of course, we're not done until we check it. So let's FOIL it out to see if it matches the original. So the product of our first two terms here would be 6xy. The outside terms have a product of -15x. Inside terms have a product of -2y. And last, a product of +5. So if I compare each term of that product to our original problem, we have an exact match. So we can be sure that our answer is correct. So remember, always look for a universal GCF first. If that doesn't exist and the polynomial has 4 terms, you can try factoring by grouping.